You're tuned in to the K-State Radio Network, and welcome once more to Agriculture Today. During our first half hour, we share a few minutes with a special guest to the K-State campus who was invited in this past week as part of the Provost Lecture Series, and she happens to be the Dean of Arts and Sciences out of the prestigious Washington University in St. Louis. And she was invited in to talk of the future challenges to agriculture and the importance of basic research in plant sciences for addressing those challenges. Our pleasure to have Mike's side, Dr. Barbara Schaal. Barbara, welcome to K-State, first of all.
Thank you. I'm absolutely delighted to be here. It's a beautiful campus, and the visit has been spectacular.
We appreciate your time here and sharing your thoughts on this broad but yet quite important topic. Your background, though, and you do have a track record in the plant science field, right?
Yes, I actually was a botany major way back in the dark ages, and I have worked on plants ever since, most recently working on rice.
Rice seems to be a universal crop when it comes to research of this type because we see rice used to explore genomes of plants in a variety of ways in the scientific field, don't we?
Certainly, it's a model system, but I think the other reason is that it feeds over half the people in the world, so it's an incredibly important source of calories, and it has tremendous economic implications.
What would you consider, before we talk of the topic that you're bringing up here at K-State, the lead advances or accomplishments that you've had the pleasure to be involved with in your research then?
Well, very early on, we were among the very first labs that were interested in looking at evolutionary relationships in plants. We were among the very first to use DNA sequences. So we began to use molecular biology in a way that hadn't been used before. And we've applied those techniques to everything from mosses to oak trees, and with everything in between. So we've studied probably about 40 different kinds of plant species, but most recently really focused on rice, in part because it is a model system, but also because it's a very important system for world agriculture, for world food supply.
You were invited in to take on this question of the future challenges to agriculture. Looking at this as a scientist, as a basic researcher, define those challenges. What do you identify as those that need to be addressed through research?
Well, I think if you look globally, the major issue for agriculture is to provide food for a growing global population. We need to provide food not only ample in calories, but also in terms of its nutritional quality. We need to address such issues as malnutrition, both of too little and also too much. So the food supply is a really important aspect of this. But then there's other things that are important for agriculture as well. Agriculture has a huge environmental footprint. We would like to reduce that environmental footprint. Likewise, water use, tremendous water use in agriculture. And of course, as somebody who studies rice, which grows in paddies, there's a lot of water there. And then finally, agriculture in general has a tremendous potential for contributing to new aspects of the economy. We call it the bioeconomy. One of the first things that one thinks about is energy, and there's been a lot of conversations about that. But with the kinds of techniques that we have now for genetic modification, plants have the opportunity, for example, to provide precursors, the foodstuffs of making pharmaceuticals, drugs. There's plastics that can be made from plants. So there's a whole host of different products, and that would be terrific not only for providing environmentally friendly products, but also for really bolstering the kinds of products that come from our agriculture, bolstering the agricultural economy of states.
Let's mine a little deeper, if we may, into several of those points. When we think about being more productive with our agricultural systems, genetic advances can lend to that. That's part of the answer. What things do you see that need to be accomplished and maybe even pursued further to help us simply produce more?
I think there's a large number of things that should be pursued all simultaneously. We never know which one of these things is going to be a breakthrough, if there is a breakthrough. Maybe it's a combination of everything, and that gives us more food. But it goes from enhancing the crop varieties, the crops that we have, and the techniques that we can use are some of the ones of genetic modification. Either the kind of classical, well, there's classical breeding, there's the genetic modification that we've seen that's already in our fields, and then there's the new developments of using a technique called CRISPR. And that is a pair of molecular scissors, and you can alter a gene that's in a plant. So you're not adding anything, you're altering it. So that will provide us with better varieties than we already have. There's also a lot of potential for new crops, as humans don't use the entire repertoire of plant species that are available for food. So there's a lot of mining that could be done by going out and looking at other kinds of crops and other kinds of plant species. Such things might have better nutrition. They might be able to withstand extreme environmental variation. They might provide new kinds of products that we haven't thought about before. There's also opportunities in precision agriculture, in just simply doing agriculture more precisely, sampling the soil as planting occurs and putting the right variety in a particular field, because we know that the soils within a field are patchy. Doing remote sensing, knowing when there needs to be irrigation, when there needs to be fertilization, and when we begin to have insect outbreaks. So that combination of precision, mechanical agriculture, new varieties of different crops, and also remote sensing I think really can help a lot in terms of using our agricultural fields for more production and also for reducing the amount of environmental footprint that we use.
And we've seen remarkable advances in technologies on all of those fronts in the last decade, maybe last 2 decades. And we've leaped forward in a lot of respects, but there's more to come, you think, there?
Absolutely. I think the CRISPR technology, I think that's very exciting. There's also some things that might be transformative, and that is using some of the aspects of synthetic biology. And that would mean, for example, what plants do is they harvest light. And there's an antenna, it's called the photosynthetic antenna, and it's not particularly efficient. So the idea of looking at, with basic research, how that antenna is constructed, how light is converted to chemical energy, and making that more efficient by taking bits and pieces of different kinds of organisms and putting them all together is very, very exciting. That could really up the production within a single field.
Have to ask you, because it's a rather standard question when the topic of genetically modified organisms comes up, and it could possibly apply to other advances in technologies, public understanding of those and receptiveness to those. As a scientist, this probably is something that you've put together some thoughts on anyway, Barbara.
Yeah, I worked quite a bit on some of these issues of genetic modification in terms of how the public perceives it. And it's obviously very, very complicated. There's been many, many studies, intense studies, looking at potential environmental impacts, potential health impacts. And those studies have really, there's no evidence for health impacts whatsoever. And there are some studies that suggest that, in fact, they're environmentally beneficial, particularly with a reduction in the amount of insecticides. So I consider genetic modification, whether it's the traditional way of doing it or whether we use the new techniques of synthetic biology or CRISPR, to be one component, several components of a toolbox, and we use the entire toolbox. I wish that there wasn't quite so much of a publicity around potential negative effects of genetically modified foods, because it's an important component of addressing all of the challenges in agriculture. I think we always need to be cautious. We always need to study whether or not something has an adverse effect. But I think focusing on just the technique is not the right approach. I think that the focus should be on what is the crop variety, what is the variety that's produced, and making sure that that's safe. And we have the regulations in place to do that.
The hope, though, would be that as the public comes to an understanding that there is no inherent evil, if you will, in these technologies, that they are, in fact, providing good, that maybe that notion will come around.
I would hope so. I think one of the things that would be very useful, and it's probably not realistic, but I've taken classes with my students, and we've gone out and gone to a farm, and the students were, I think, considering that they didn't like GMO foods. They were very concerned about it. And then they met a farmer that actually planted genetically modified corn. And his comments about, the first time I saw this, it was the most beautiful field I've ever seen. My yield has gone up. This is fantastic. And I think the students were very surprised by that. So I think it's important for agriculture to have a voice in this, and not just have scientists talk about it, but I think people trust farmers.
The environmental footprint, as you've mentioned a couple of times, and how that can be addressed through research, through basic science. What are your thoughts along that line?
Well, there's a number of ways of addressing that. I think one is making plants more efficient, doing a better job of, for example, obtaining nitrogen from the soil, doing a better job of obtaining water, being more drought resistant. That will reduce some of the inputs to agriculture. I also think there's a potential, if we have very high production crops, of reducing some of the farmland. Now, that probably goes in conflict with producing more food, but I think doing a better job of farming the land that we have will actually help the environment. And I think all of these techniques, by making agriculture more efficient, just reduces the amount of runoff, it reduces the amount of usage of pesticides and chemicals and other kinds of inputs.
Our guest here on Agriculture Today, plant scientist Barbara Schaal of Washington University, St. Louis, a guest on the K-State campus currently, and we'll continue our visit with Barbara in just a moment after this break. You're listening to the K-State Radio Network.
Agriculture and food systems are the main drivers of the Kansas economy, but must be improved in order to feed the world's growing population. How are we going to do so? Reduce food loss, find ways to preserve grasslands, and help families stretch their dollars. Global food systems is one of the 5 grand challenges K-State Research and Extension is addressing. To learn more, visit www.ksre.ksu.edu.
Agriculture Today is back now and continuing our visit with an accomplished plant scientist who's a guest speaker here on the K-State campus. Out of the prestigious Washington University in St. Louis, Barbara Schaal is sharing her thoughts on the future direction of plant science of interest to agriculture. And Barbara, if we might venture for a second here into funding for basic agricultural research. And public funding for such has taken a few hits in recent years. Your thoughts on what needs to be done to fortify the funding for basic plant science research?
Well, I think that is a huge concern, and it's one that's been called out nationally by many different groups, the National Academy of Sciences, the U.S. Department of Agriculture, and private groups and foundations as well. And I think the concern is that we do have these challenges. And all these challenges, by the way, are going to be occurring in the face of a climate that's changing. And so that adds additional challenges. The only way to really address this is to provide the basic discoveries that will allow us to adapt, will allow us to work and develop new crops that will respond to climate change. And that requires basic research. And it requires applied research, and both those things require money. I think one of the great things that has happened in agriculture in the United States is the extension service, the kind of applied research that I've had the privilege of seeing here at Kansas State. And there's also the basic research that feeds both of those missions, and we need to make sure that that's strong. If we don't have those new discoveries that will ultimately lead to new crops and to new ways of tackling these issues, we won't, in the future, we won't be able to have new crop varieties. We'll have a desert of ideas and a desert of discovery. And that is really a concern, maybe not so much for someone who's middle age, but when we think about our children and our grandchildren. So it's really vital that we keep that discovery pipeline going. So we need funding. We need to have judicious use of funding. We need to be able to balance basic research and applied research. And we need to also, I think, not only universities such as K-State, but also industry is part of this, foundations are part of this, and there needs to be partnerships.
Research collaboration beyond what we've seen already to this point.
I think absolutely. And I think both the public and private will benefit by that. One of the things that we've done in one of the studies that I've worked on was to look at what kinds of things industry investigates and what kinds of things very often USDA, Department of Agriculture, and universities investigate. And sometimes there's actually overlap in terms of the kinds of questions and the kinds of species that are used. If we could, for example, just simply coordinate all of that, we could broaden the expanse of what we do in terms of research. And then industry is very, very sophisticated. I say this as a lab scientist, they have beautiful equipment, the support is tremendous, and to be able to have access to that for scientists at universities would be a great thing. I think there's a real opportunity for partnerships where everybody benefits.
We could speculate on the future quite a bit here. Barbara, as you look at it, what's the next great thing on the horizon in the area of plant science? And that could be technology, that could be a focus of research. What comes to your mind immediately?
The first thing that comes to mind is just what I mentioned before, and that is engineering photosynthesis. So that the actual light harvesting, the capture of energy, which then is put into our grains and our vegetables and the fruits, that harvesting of energy, if that could be improved, that could be transformative. That would be the opportunity to not just tweak yields a little bit higher every year, but to actually really have a large jump in yields. And there are a number of different laboratories working on that. That is speculative. It may work, it may not work, but that's the kind of thinking that I think we need. We need to have scientists who understand agriculture and have them work on things that are transformative. There's lots of people that are working on small incremental changes to things, but we need the big ideas. Sort of like you have a big idea in terms of the internet and Google. Those are the kinds of advances that we need.
When you say the photosynthesis enhancement may be the next step, are we close to that becoming functional at this point?
Well, people are working on it. People are working on using synthetic biology and genetic engineering to try to tweak the photosynthetic apparatus. So they're figuring how to do that, how to make that actual function work better. But once that's done, then it has to be put into a plant. And then, as we all know, it's not just one plant, but you're going to have multiple varieties of plants of one crop and then multiple crops. So that's a ways off. But I think we need to be thinking like that. Mm-hmm. In addition to doing just the really good boots-on-the-ground crop improvement that's done by plant breeders and by the industry.
We know so much more about plant genomes than we did 5 years ago, 10 years ago. Do we know enough, or is there more to explore?
I think there's more to explore, and particularly when you start thinking about, you don't want to do just one genome. You want to do multiple genomes for a crop. So, for example, in rice, which I'm most familiar with, they've done lots and lots of different varieties of rice, looking at the genome, and then lots of different populations of wild rice, the wild ancestor, which was the plant that was domesticated by humans. And what that does is it gives you an idea. You can do data analysis, and it will give you an idea of what the genes are that give particular adaptations. And that's what we're interested in, is understanding which combination of genes allows you, for example, to have dry land rice, which I've seen growing and is quite unusual. So these are the kinds of opportunities. I think there's a lot to be done there. There's also a lot to be done, I think, looking at other species of plants that have potential for being domesticated and for being used for food and for fiber. And understanding the genes that, for example, give a particular product is important. Plants are amazing biochemists. They produce this amazing diversity repertoire of biochemicals. Many of them have, throughout the history of humans, been used for medicines. There's all kinds of other chemicals. Some of those are going to be very useful, and there's a lot of discovery there. Understanding the genes which produce those chemicals, the biochemical synthetic pathway, genomics can help with all of that. So there's a lot of applications.
There are possibilities untold here, it sounds, and it's a matter of getting the inertia behind the efforts here and the fact that there may be an economic return to many of these advances. Could that push the agenda, if you will?
I think it could. I think people are very interested in expanding the kinds of products that are produced by plants. The nice thing about plants is they're relatively inexpensive to produce. So you could have a field of corn that you harvest, and it leads to a precursor of a very important and potentially very expensive drug. So those are the kinds of things that are exciting, not only for the benefit that they provide, but for what it means for the economy of a farm and of a region. And I know that people that are interested in rural economy are very interested in providing the kinds of crops that have very, very high value, kind of like some of the electronics have very high value. I could see something analogous in plant biology, where you produce these enormously important compounds that are then used for medicines and other sorts of things. That would be fabulous.
And you're hinting at this, the appreciation of basic research in these areas agriculturally. Certainly growers out there understand with the advent of GMOs, et cetera, but the public at large, maybe a broader appreciation of where we might be headed with all of this is in order here.
Yeah, I think it's very important that the public understands, and particularly those of us that work in agriculture, whether you are a farmer or a research scientist, understand the value of this basic research, which looks at trying to understand how plants do what they do. How do plants take sunlight and convert it into products, into grain, and that we harvest? How do plants take nutrients from the soil? Understanding all of these things better means that we can give that information to breeders. It can be tweaked, and we have bred varieties. But if we don't understand how plants photosynthesize, if we don't understand how they pull nutrients from the soil, we can't improve it. There's a limitation to what we can do. Yeah. A deep understanding will allow us to not only improve it, but do it fast.
What's next on your plate as far as your research program?
I'm going to be doing some work that is more conceptual. I'm interested in looking at some of the policy issues surrounding genetically modified foods and looking at some of the issues related to the environment. I think those are really interesting things. We need to have our elected officials understand agriculture. I'm also going to be working on trying to promote a little more of the kind of research agenda that we need for agriculture. And the fact that food is so plenty means that people really don't see the urgency either. And so I feel a real obligation to try to make some of our policymakers understand that we need to be paying attention to agriculture as well as healthcare and all of the other things that challenge us.
Barbara, it's been a pleasure having you here on the K-State campus, and thank you for sparing a few moments with us right here during your visit, and the best of luck in all these endeavors.
Well, thank you very much. This has been a very enjoyable visit.
Barbara Schaal with us. She is the Dean of the Faculty of Arts and Sciences at Washington University in St. Louis, and by trade she is a plant geneticist with a long history of research in this area. She was brought to K-State as the latest presenter in the Provost Lecture Series on Excellence in Scholarship, where she talked about the future challenges to agriculture and the importance of basic research in plant sciences for addressing those challenges. She's been our guest on this part of Agriculture Today. We'll step aside now and be back with more after this break. You're listening to the K-State Radio Network.
Have you ever thought about where your food comes from? If you're thinking the grocery store, think again. Facts show that the American farmer feeds more than 129 people.
They are continually increasing and improving their operations. A wide variety of crops and livestock are grown in Kansas as well as the United States, providing food to your dinner plate.
Next time you see a farmer or rancher, thank them. For more information, contact K-State Research and Extension.
This is Agriculture Today. Stop, look, and listen. This is our state, Kansas.
In every organization, there are a select few employees who would be difficult to replace.
That's Gus Vanderhoeven of Kansas State University with comment on life in rural Kansas.
A good friend sent me the following email, and after reading it, I forwarded it to my 5 children. I added my own remarks, pointing out that the order of the 5 names was not meant as a ranking by importance or love. It was just how the names popped up. Ian, Guido Martin, Talina, and Jonneke. The article my friend sent was entitled, "Who Inherits the Farm?" I'll quote the article. Maybe you have read it. I don't know where he found it. It's an interesting article, and in reality, it happens just as the article describes. Here's the article he sent me. A certain farmer had become old and ready to pass his farm down to one of his 2 sons. When he brought his sons together to speak about it, he told them, "The farm will go to the younger son." The older son was furious. "What are you talking about?" he fumed. The father sat patiently down, thinking. "Okay," the father said, "I need you to do something for me. We need more stock, more cattle. Will you go to CB's farm and see if he has any cows for sale?" The older son shortly returned and reported, "Father, CB has 6 cows for sale." The father graciously thanked the older son for his work. He then turned to the younger son and said, "I need you to do something for me. We need more stock, more cattle. Will you go to CB's farm and see if he has any cows for sale?" The younger son did as he was asked. And a short while later he returned and reported, "Father, CB has 6 cows for sale. Each cow will cost 2,000 rupees. If we are thinking about buying more than 6 cows, CB said he would be willing to reduce the price 100 rupees. CB also said they're getting special Jersey cows next week. If we aren't in a hurry, it may be good to wait. However, if we need the cows urgently, CB said he would deliver the cows tomorrow." The father graciously thanked the younger son for his work. He then turned to the older son and said, "That is why your younger brother is getting the farm." Most people only do what they are asked, doing only the minimum requirement. They need specific instructions on most things they do. Conversely, those who become successful are anxiously engaged in a good cause. They don't need to be managed in all things. They don't just do the job, they do it right and complete. They also influence the direction of how certain ideas and projects go. Most importantly, those who become successful initiate. They reach out to people, ask questions, make recommendations, offer to help, and pitch their ideas. Being successful requires being proactive and not waiting for life to come to you. It means you're on offensive, not defensive. You're active, not passive. In every organization, there are a select few employees who would be difficult to replace. For the most part, most people are like the older son in this story. Most people could be easily replaced. Most people are passive and reactive. They require specific instructions. They need to be governed and managed in all things. Initiation always involves some degree of risk. You're putting yourself out there, and there's a chance you could fail. Conversely, doing only what you're told entails no risk and carries no responsibility. It's playing safe. There's nothing new in the article I just read. It's a life experience which happens many times over, where a family's business is passed on or is wished to be passed on. Only for me, a farm is different than a business because there is the land. Different farms or different ranches have different character. And to me, it is the character of the land, whether it is ranch, farm, or a combination of the two, that speaks and means a lot. Remember the walk I made on our farm not so long ago, walking the woods and seeing the beautiful dropped antler in the dead leaves on a cold day? When I hold them today, I still feel the thrill of finding them. That thrill had nothing to do with the beef cattle grazing on top of the hills in summer, nor with the stand of brome hay, nor the fences or the many things that always need to be done. It is the love for the land, the deep sense of place. But as the article says, successful people initiate. And I know for that land to be successful, farm property, one has to understand and initiate. Come to think of it, this test, needing 6 more cows, would not have worked with my 5 children. Because even though each of the 5 is different, an individual, they all have initiative. They all have drive.
Gus Vander Hoeven of Kansas State University with his weekly commentary on rural Kansas. That'll do it for this Wednesday edition. Thanks for listening in. Eric Atkinson here. This has been Agriculture Today over the K-State Radio Network.